And
Allumage
liftoff.
UAP, décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
When the rockets of the Ariane 5 launch vehicle fired on the morning of December 25, 2021, the ground in French Guiana physically trembled. The James Webb Space Telescope, JWST, began its month-long trip to its current location, approximately 930,000 miles, 1.5 million kilometers, from Earth, with a roar. It took 5 more months for engineers and scientists to prepare the 6.5-meter telescope for use, but the wait was worthwhile. JWST has changed the way we think about the universe. Call it beautiful, stunning, or extravagant. This is the side of the universe we would have never seen without the JWST. Pillars of creation. In the pillars of creation, a famous area where new stars develop within dense clouds of gas and dust, it took a breathtaking, incredibly detailed picture. In reality, the tall pillars, which resemble magnificent rock formations, are composed of chilly, interstellar gas and dust that, when illuminated by near-infrared light, can appear semi-transparent. Scientists can use this new image of the pillars, which were first made famous by NASA's Hubble Space Telescope in 1995, to update their models of how stars develop. Because of Webb's improved vision, scientists can count freshly born stars more precisely and have a better sense of the amount of gas and dust present in the region. Thanks to this data, they will be better able to comprehend how stars grow and emerge from these dusty clouds over millions of years. Webb's near-infrared camera, NIRCam, captured this stunning image which highlights newly created stars. These vivid red orbs reside outside the dusty pillars and are frequently encircled by diffraction spikes. Once knots of dust and gas have accumulated enough mass, they heat up, collapse under their own weight, and eventually become new stars. Jets of material are being expelled by stars that are still developing, which is why certain pillars have wavy lines at their edges that resemble flowing lava. Every so often, young stars release supersonic jets that crash with nearby gas and dust clouds, causing shockwaves that resemble a boat's wake on water and generate wavy patterns. From these jets and shocks, energetic hydrogen molecules are produced, which give off the crimson light. The image almost pulses with activity in the second and third pillars, which are visible from the top. A few 100,000 years is all that these young stars are. Although it may appear like Webb's near-infrared light has made it possible for humans to see far into space and through clouds, this image hardly contains any galaxies. Rather, our vision of farther-off regions of the universe is obscured by the dense mixture of gas and dust in the Milky Way's disk. First photographed by Hubble in 1995, this image was re-examined in 2014. As more information about this star-rich region is revealed by each new instrument, numerous other observatories have also turned their attention to it. The cosmic dust in your bones. Cosmic dust is very important to the universe's functioning because it can contain the organic molecules that give rise to life as we know it, shield developing stars, and form planets. We were guided by dust. The primary issue in astronomy, according to Ryan Lau of the Japan Aerospace Exploration Agency, is that not all of the dust seen in galaxies, both in the close and far-off early cosmos, can be explained by what is known as the dust budget crisis. With the help of NASA's future James Webb Space Telescope, Lau is spearheading a director's discretionary early release science program to investigate Wolf-Rayet binary stars that produce dust. Wolf-Rayet stars are extremely brilliant and hot. There is proof that when Wolf-Rayet stars interact with a companion star, they create a lot of dust in the shape of a pinwheel when their stellar winds collide and they orbit one another. These binary star systems might be responsible for a significant portion of a galaxy's dust budget. However, it has been challenging to investigate the fainter, more diffuse dust of these systems due to the high heat and light from the Wolf-Rayet stars. Webb enters the picture here. Lau says, "We want to look at the mid-infrared light that Webb can detect in order to study the dust and its chemical composition. Because infrared wavelengths are longer than visible light wavelengths, they can pass through dust grains and reach the telescope instead of getting trapped in the dust cloud and bouncing around. Astronomers will be able to read the information carried by this light, which Webb will detect, including the signature of molecules in the dusty environment, some of which might be the same chemicals that make up the foundation of life on Earth." Lau and the director's Discretionary Early Release Science (DDERS) team will use Webb to investigate two Wolf-Rayet binary systems with the telescope's mid-infrared instrument, MIRI, a near-infrared imager and slitless spectrograph, NIRISS. The WR140 binary system has been widely researched at numerous light wavelengths, therefore it will serve as a suitable baseline for determining Webb's optimal observation modes for this type of cosmic subject. Another Wolf-Rayet binary, WR137, will have its stars come closest together when the greatest dust is expected to be produced, early in Webb's mission, when the DDERS program observations are planned. Both Lau and Castley believe that, while the open subject of how cosmic dust is formed and dispersed throughout the cosmos is fascinating, it is only a stepping stone towards answering one of the most fundamental mysteries of all time. How did we get here?
Dust from space constantly falls from the sky, 10,000 tons a year.
As far as we know, Earth is an island of life in the cosmos, and Lau claims that by attempting to understand something as obviously remote as cosmic dust, we are ultimately looking to understand ourselves.
And it is everywhere. It is on the streets, in our homes, on the roofs of our houses, and even on our clothes.
Understanding the formation of dust is critical for us to trace our own cosmic origins, according to Lau. Webb is one of the most powerful scientific tools ever built in the quest to find answers to these fundamental questions. Rings around the Ring Nebula. NASA's James Webb Space Telescope has observed the well-known Ring Nebula in stunning clarity. The Ring Nebula is a classic planetary nebula formed when a star loses its outer layers due to a lack of fuel. It is also known as M57 and NGC 6720, and it is only about 2,500 light-years away. This latest image from Webb's NIRCAM near-infrared camera has unparalleled spatial resolution and spectral sensitivity. This information, for example, makes the delicate intricacies of the inner ring's filament structure stand out. The nebula has about 20,000 compact globules that are rich in molecular hydrogen. In contrast, the inner region contains very hot gas. The primary shell has a thin ring of enhanced emission from carbon-based compounds known as polycyclic aromatic hydrocarbons. Approximately 10 concentric arcs are positioned just beyond the outside edge of the main ring. The arcs are supposed to be caused by the interaction of the central star with a low-mass companion, orbiting at a distance comparable to that of Earth and Pluto. In this way, nebulae such as the Ring Nebula disclose an aspect of astronomical archaeology, as scientists analyze the nebula to learn more about the star that generated it. Life on a distant planet. Scientists have discovered new preliminary evidence that a distant planet orbiting another star may be home to life. A Cambridge team examining the atmosphere of the planet, K218b, discovered compounds produced solely by primitive species on Earth. NASA's James Webb Space Telescope, JWST, has found molecules linked with life in the planet's atmosphere for the second time, and this is more hopeful. However, the team and other astronomers emphasize that more evidence is needed to corroborate these findings, the mystery of jumbos. Astronomers made a shocking finding in the Ring Nebula towards the end of 2023. Using the James Webb Space Telescope, JWST, the researchers discovered 40 pairs of planetary mass objects, none of which orbit a star. They're known as Jupiter Mass Binary Objects, or JUMBOS. In a nutshell, this revelation directly contradicted both star birth and planet formation theories. The origins of these orbs remained unknown, and it was unclear how such a huge number of pairs of these entities ended up wandering the Orion star nursery, which is around 1,350 light-years from Earth. Now, a team of astrophysicists from the University of Nevada and Stony Brook University believe they have solved the puzzle. The team proposes a convincing hypothesis for how these unusual entities could have been evicted from their home systems and gone rogue while remaining linked with a binary mate. If the findings are right, they have the potential to transform our understanding of global evolution. However, jumbos will most likely take a different path to reality. The probability of a star having a binary partner, for example, reduces considerably as the masses of those stars decrease. For example, over 75% of large stars live in binary pairings, whereas only 50% of stars with masses comparable to the Sun have a stellar partner. And the likelihood of discovering a brown dwarf in a binary, with masses roughly 0.75 times that of the Sun, is vanishingly low, nearing 0%. Brown dwarfs have masses around 75 times that of Jupiter. Thus, stars less massive than this should never be found in binaries, certainly not in large enough numbers to form a nebula with 40 stars. Jumbos have masses in the lower range of brown dwarfs, less than 13 times Jupiter's mass. So, what's happening?
And so, by this definition, OTS-44 is not a brown dwarf either. It really does look like a massive planet, just bizarrely hanging out in the depths of space, all by itself.
Furthermore, jumbos cannot be explained using typical planetary formation models. These are models that would predict their formation from residual gas surrounding a parent star, or stars, if working with a binary system. That is because, while we know that planets are frequently driven out of their home systems to become rogue planets, or cosmic orphans wandering the cosmos without a parent star, this process should be so violent that it tears apart any possible gravitationally bound planets. The discovery of 40 pairs of jumbos in the Ring Nebula alone appears to rule out a strange ejection event that resulted in a planetary pair being ejected together rather than separated. The team's findings pave the way for further jumbo studies, maybe with the instrument that helped uncover these star pairings, the JWST. It also informs researchers that planet creation is a more diverse and fascinating process than previously thought. But which of these discoveries fascinated you the most? And what do you think lies beyond the grasp of humanity's most advanced telescope? Make sure to share your thoughts, and if you like this video, drop a like and subscribe if you haven't already. Thanks for watching.